All right, so we're going to start our chapter on inequalities. So first we're going to talk about writing, graphing, and trying to find the solutions to an inequality. We'll talk about why we graph them. And then we're going to solve some using addition and subtraction. Now the nice thing is we solve inequalities the exact same way we solve equations. It's just what we do with the solutions that's a little different. Okay, so some vocabulary for you. The solution of an inequality, okay, is the same thing as the solution to an equation. In other words, it's any number that I can plug into the variable into an inequality that makes the inequality true. Same thing for an equation. Any number I can plug in for the variable and make the equation true. How do we find the solutions? Well, we do the same thing we did with equations. We made equivalent equations. So we added numbers or divided numbers or multiply the same numbers to both sides of an equation to create equivalent equations to make the solution stand out more, right? The same thing for inequalities. We're going to rewrite inequalities into equivalent inequalities so that we can more easily see the solution, okay? So first things first, how do you write them? And in the very beginning of the school year, we had to come up with the difference between writing subtraction or the less than sign or addition and the more than sign or greater than sign, right? And we're going to talk about that difference a little bit now. First of all, if we're going to write all real numbers less than or equal to -5, all real numbers, we don't know what numbers we're talking about exactly, so let that be x, are less than or equal to -5. Pretty straightforward. That's what your inequality should look like. Okay? Now this one says 5 less than a number is greater than or equal to 23. Now there's less than here and greater than there. So we don't want to write two inequality signs for the same inequality. So we got to tell the difference between when we're supposed to write an inequality versus another type of sign. Less than suggests subtracting. If I want to know what 5 less than a number is, I'm going to start with the number and subtract 5 from it. Now this says is, now the next part is greater than. That word is what triggers the inequality sign for me. This part is greater than the other parts. We need an inequality sign. This didn't have an is in front of it, so we don't need an inequality sign there. So to write this thing out, 5 less than a number. We've talked about this. Less than is a phrase that makes you flip-flop the order. So we got to go x minus 5 is greater than or equal to. So we need the greater than or equal to symbol. 23. So there's your inequality. Okay? Try this one. Try to write this one out. Okay, so what did you get? 3 more than the product of a number and 14. Remember, a product and a number is just 14x. 3 more than. I have to know what 14x is first, and then I can add 3 to it. Now, the word is not in front of more than, so it's not a greater than inequality symbol. It's just adding 3. Now, the next part says is less than. There's the is. So you're going to write the inequality sign for less than 45. And so there's our inequality. Okay? All right, solutions. How do we find, how do we determine if a number is a solution to an inequality? Well, it's the same as for an equation, right? When you solved an equation, how did you know that equation, that solution was the right one? How did you know that you got the right answer? Well, you should know that you should be able to plug that number into the variable and it make the equation true. The same thing for an inequality. So we're going to substitute the value into the inequality for the variables and then see if the inequality is still true. If it is, it's a solution. If it's not a solution. So for example, if I want to know if -3 is a solution to this inequality, then I'm going to quite literally take this -3 and plug it in for that x. So instead of taking 2 times x, I'm going to take 2 times negative 3. Right? 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. And we get negative 5 is greater than negative 3. Is negative 5 greater than negative 3? No, it's not. So, negative 3 must not be a solution. Okay. What about negative 1? Check to see if negative 1 is a solution. You stop the video, start it back up, and see if you got it right. Okay, so again, I'm going to literally plug negative 1 in for x. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Now, negative 1, is it greater than negative 3? And the answer to that is yes. So this is a solution. Okay? All right. Now, graphing. Why are we graphing inequalities? All right, so we're talking about why are we graphing inequalities, right? Well, it's the nature of solutions of inequalities, right? So when we solve down an equation, x equals 4, right? What's the solution when we see x equals 4? Well, pretty straightforward. The solution is 4. We should be able to take 4, plug it back up into whatever original equation there was, and plug that 4 in for any variable, and make the equation true, right? Well, when we solve down an inequality, we might get something like x is less than 4. Well, what's the solution then? Well, hopefully you're thinking, well, is 3 a solution? Well, 3 is less than 4, right? What about 2? What about 1? What about 0? What about negative 1? What about negative 2? What about negative 3? Okay? All of those are solutions. And so the last thing we want to do is write out every single last bit of a solution to an inequality. It takes too long. There's an infinite number of solutions. It goes on forever and ever and ever. Right? So we graph them. Could we graph the solution to an equation? Sure. You can create a quick number line here, plot out 0 and 4, and then put a dot there. But it's unnecessary because there's only one solution and we can write it out. We use a number line to help us show the solutions to an inequality because there's too many to write them all out. So there's a way to do that, right? Now, step 1 says you're going to label the number line with the number in the inequality. And that's true. So when you solve this down, you're going to get x is, let's just say x is less than 4. So you're going to label the number line with the 4 on it. Now, I always like just putting 0 in the proper place on the number line compared to whatever number I just put on the number line. And that's to show location. Here's 4. And it's to the right of 0, and so now we're going to shade. Now this suggests that you put one integer larger and one integer smaller than the number in the inequality. And that might make enough sense too. So we can put a 3 here and a 5 here. And when we do that, that might actually help us figure out which way we're supposed to shade. Now, we're going to shade the number line, and we're going to shade the number line with to show the solutions. So for x is less than 4, we're going to shade all the solutions. What did you say? You said that 3 was a solution. You said that 2 was a solution. You said that 1 was a solution, right? So it's all of these numbers over here to the left. And we can keep going, smaller and smaller and smaller and smaller. Now, the question is 4 a solution? Is 4 less than 4? The answer is no. So I don't want to shade that number in. So what we do is we put a circle around 4, but we don't color it in to show that we want everything up to 4 as a solution, but not 4. Okay? If 4 were a solution, I'd want to color that in too, and we'll take a look at what that looks like in just a second. Okay? So graph the solution to this inequality, x is greater than 5. Right? Well, we're going to put a 5 here, 4 here, 6 here. Okay? And we need to show, we need to graph, we need to shade the solutions. Now, what are the solutions when x is greater than 5? Well, I want everything bigger than 5. So we're going this way. Now, 5 is not a solution. 5 is not greater than 5. So we're going to put an open circle on 5. We're not going to color it in. If it were a solution, we'd color in that circle. And we're done. Okay, what about this guy? Negative 8 is greater than p. Think about that for a second. What would that look like? Negative 8 is greater than p. All right, well, we're going to put negative 8 here, negative 7, negative 9. Negative 8 is greater than p. Negative 8 is greater than. So I need negative 8 to be larger. What did I do? Did you just see this? Duh. Negative 9 goes on this side, negative 7 goes on this side. But I need solutions. The solutions are all the numbers where negative 8 is greater than. Right? Where are the numbers that negative 8 is greater than? Right? Negative 8 is bigger. So I need these numbers going this way. All right? And so I don't want to include negative 8. Negative 8 is not bigger than negative 8. So open circle here. And then we're done. Okay? Now be careful. Be careful to read the inequality to know which way you're supposed to shade. Now, I know some of you guys want to do this. You're going to want to do this. You've always been taught to have the variable listed first, because that will help. There's a couple of tips and tricks to shading these inequalities, but as long as the variable is written first. So you can flip this around, but when you do, you've got to flip the inequality as well. If the corner of the inequality is pointing at the p, when you flip it, the corner of the inequality should still be pointing at the p. So now this says p is less than negative 8, and that might make more sense to help you shade to the left. Not to mention there's a trick that says as long as the variable is first, you get this arrow that points to the left. Okay? But if you're going to do that, make sure you flip the inequality. All right? Kind of the same deal for here, but try to graph this guy. Stop the video. Start it back up, and make sure you're right. Did you get this? Hopefully you did, right? Negative 4 is less than or equal to q. If you want to flip this around, that's fine, but make sure you flip the inequality sign to say q is greater than or equal to negative 4. So greater than would be the other way, right? Now we need a closed circle because this is the first time where negative 4 actually is a solution. If you plug in negative 4 for q, the negative 4 is not greater than negative 4, but it is equal to negative 4. And so it is a solution. So we want to make sure that we include that in our shading, and so we close that circle up. Okay? All right. Now, we're going to talk about solving, right? And solving an inequality is the exact same way as solving an equation. Right now, if we have g plus 2 is greater than or equal to 6, then it becomes really tough to see where to start your graphing to show the solutions. So what we do is we isolate the g, just like we did before. Subtract 2 from both sides. So g is greater than or equal to 4. Okay? And that's it, as far as solving this goes. Right now we want to graph it. Right, so we're here at 4, 3, 5. Now, open circle or closed? Should be closed on 4, because 4 is equal to 4. G is greater than, so we want all the numbers that are greater than 4. And so we're there. Okay? Good. How about this guy? Try this. You can stop the video, give it a shot, and then see what you come up with. Okay, what did you get? We've got to add 4 to both sides, which we know. So we get 7 is greater than m, or if you want to flip it around, m is less than 7. So to graph, we put 7 here, 6 here, 8 here. Open circle or closed? Well, it should be open because 7 is not less than 7. Okay, m is less than, so we want to go this way. Okay. All right, try this one. Stop the video, start it back up, and see if you're right. Did you get this? Right? Add 5 to both sides. So r is greater than -5. Okay? Another way to tell which way you should be shading is the two numbers that you're placing on either side of the -5, you can plug it in and see which one works. But read the inequality. R is greater than -5. So I need all the numbers that are greater than -5. Right? And again, it's an open circle because it's not equal to, right? -5 is not a solution. -5 is not greater than -5. Okay? Good. All right, now we need to start getting good about modeling, right? We want to model certain situations with inequalities, right? So the first one, to play in McDonald's Playland, you must be under 6 years old. How would you write that as an inequality? You must be under 6 years old. How about x is less than 6, where x is h? Make sure you define your variable here, right? Since we're in a particular context, particular situation. And it's not equal to, right? Once you're 6, you can't play there anymore. It says under 6. So it's just going to be less than 6. Okay, what about this? To ride the mammoth at Holiday World, you must be at least 48 inches tall. How would you write that? You must be at least 48 inches tall. At least suggests that you have to be 48 or more. So x needs to be greater than or equal to 48 inches, where x is your height. Okay? All right. I'm going to combine that with solving a little bit and get into some story problems. An amusement park charges $35 for admission and 75 cents per ride. You go to the park with 60 bucks. Write an inequality that represents the number of rides you can go on. What is the maximum number of rides you can go on? So what are we trying to figure out? Well, we're trying to figure out the number of rides you can go on. So x is our number of rides. Now, what do we know? You're taking 60 bucks with you, right? That's all you can spend. Can you spend $60 exactly? Sure. So how much you spend can be equal to 60 bucks, but you're okay if you spend less, right? If you take some money home, right? So it's got to be less than or equal to. Now, how do you figure out how much you spent? Well, they're going to charge you $35 just for walking in the door, but they're going to add to that 75 cents per ride. Remember, the word per indicates multiplying. So 75 cents per ride, and x is supposed to be the rides. So there's your inequality. 0.75x plus 35 is less than or equal to 60. A little bit unfair because we haven't talked about using division to solve an inequality, but that's okay because, like I said before, most of the time you're going to do this the exact same way you would do an equation. And we know that we're going to divide by 0.75. And when we do, we get 33.3 repeating. right? So x is less than or equal to 33.3 repeating. Remember, x is the number of rides. So what does that mean? That means that I can ride no more than 33 rides, right? No more than 33 rides. Can't ride the 34th if you don't have enough money, right? But we can ride less than 33 rides. It's not a problem. All right? So just trying to figure out how to write inequalities for story problems. Here's one. The school is taking students to Kings Island. The bus can hold no more than 63 students. There are 27 students signed up for the trip. Write and solve an inequality that shows how many more students can sign up. Stop the video, give it a shot, and see what happens. All right, so what did you do? Well, we need to know how many more students can go. So x can be the number of additional students. Right? So the bus can hold no more than 63. So whatever number of students we take, it needs to be less than or equal to 63. Right? Now there's already 27 on there, so how many additional we try to put on, we have to add 27 to that, and that's going to have to be less than or equal to 63. We can definitely take less than 63, we just can't take more. So by the time we're done subtracting 27, right, x is less than or equal to 36, which means we can take no more than 36 additional students. All right, we'll try one more. Club has a goal to sell at least 25 plants for a fundraiser. They sold 8 on Wednesday, 9 on Thursday. What are the possible numbers of plants the club can sell on Friday to meet their goal? Write an inequality. Okay. Try to set this up. Stop the video, and then you can start it back up to see how you did. Okay, did you do this? Did you use x instead of p? If you did, that's fine. But our variable is going to stand for the number of plants. Right, we sold 8 on Wednesday, 9 on Thursday, so those are going to add to however many we sell on Friday, which is P. That amount, that additional, that when you add that together, that needs to be bigger than or equal to 25. We can sell more than 25. We'd be okay with that. Right? So then we need to solve. So combine 8 and 9 and get 17. Subtract 17 from both sides, and bam, there you go. P is greater than or equal to 8. So we need to sell 8 or more to meet their goal, to meet the goal. Okay? All right. That's all there is to it. Inequalities, at least in the initial sense, the easy sense. We'll talk about more ways of solving inequalities next time. Your homework's out in Canvas. Make sure you get that done by next time.